Alright, so students, in this video we're going to look at how to calculate gradient. Alright, so by the end of this video you should be able to calculate the gradient of a line from a graph or the gradient of a line between 2 points and also interpret what the gradient actually means in its context. Key things to remember are the definition of a linear relation, so that is where we've got a series of points or sets of coordinates that, when plotted, form a nice straight line, better than the one I just drew. And the other thing to remember is gradient. My gradient is a measure of how steep a line is, or it's a rate of how one variable changes with the other. So gradient can be positive, where the line is increasing. Gradient can be negative, where a line is decreasing. Gradient can be 0 if it's a flat line. Gradient can also be undefined if it's a vertical line. All right, now to calculate gradients, there's basically just one formula, but it can be expressed in 3 different ways. So 1, 2, 3, they are all the same formula. So the idea will be to pick one, maybe 2, and really just get a hang of it, use it, and be familiarize yourself with it. So gradient is, so the basic formula for gradient where if we've got a line here and we have 2 points on our line, here and here, we've got some horizontal distance underneath the point, then some vertical distance here, and a right angle triangle there. So this distance along the bottom, we call that our run. So we're asking there, how far have we moved across in the x direction, and then our rise is how far up we go. Now, that's our first formula. The second way of thinking about this, guys, is actually considering it as though we've got a Cartesian plane here, where we've got our y-axis going up and our x-axis going that way. Let's say this coordinate is 1 and this one is 3. Let's say that one is 2 and up there that one can be 6. Okay. Now, how we can calculate the rise here is by doing 6 subtract 2. And that's what's going on in this second formula. Right, that rise is 6 take 2. Right, that's how far up we've gone. We've started at 2, we've gone up to 6. That's 4 places. For our run here, we started at 3, 1, we've gotten to 3, we've moved 2 places there. And that will be our x2 minus x1. So this formula here basically does the same thing. It's saying we're calculating the rise by subtracting our y coordinates, and we're calculating the run by subtracting our x coordinates. And that tells us those distances. This last formula is basically the same as rise over run, it's the same as these two. Delta is a Greek letter. In science and maths, it means change in. Okay? And in this case, change in means subtract. So the change in our y coordinate, so we started at 2, finished at 6, the change in our y coordinate is 4. We've gone from 2 up to 6. In the same way, the change in our x coordinate, we started at 1, we finished at 2. The change in our x coordinate there is 2. So all 3 formulas, they mean the same thing. It's rise over run. They're just a few different ways of calculating it or thinking about it. We can subtract our y values, or we can express it this way as change in y over change in x. But again, the whole idea is we're subtracting our y variables, or we're working out how far we've moved in the x direction and in the y direction. All right, when determining the gradient of a line from a graph, we have to identify the coordinates of 2 points on the line, and then from there apply our formula, work out rise over run or change in y over change in x, and then determine our gradient from those values. So we've got some equations here. Let's call this one A and this one B. All right, so for A, We'll pick 2 points on our line. Let's say this one here, which is -3, 4, and this one here, which is 1, 4. Now, looking at those points, if we want to talk about our run or the change in our x value, well, from 3 to 1, we've moved 4 places. And we can just work that out again by subtraction. 1 subtract -3, that's the same as 4. But our run is 4. Now, what about our rise? Our rise, or our change in y, well, just looking at it, it's 0. We haven't gone up or down at all when we're looking at that first purple line. And that sort of makes sense, using that's 4 take 4, which is going to be 0. So our gradient then is going to be rise over run, or change in y over change in x. That's 0 over 4, which equals 0. We've got a flat line here, and that makes sense. Right? The gradient of our horizontal line should actually be 0. Now, let's look at our second one. Looking at our coordinates, let's pick this point here. That's 0, 2. And let's pick this point up here. That is 4, 6. Okay. So once again, if we're going to do our run first, or our change in x, or our run, we've gone from 0 to 4. So that's 4 places, is that distance there. And then from 2 up to 6, that's 4 places too. Our change in our y coordinate is also 4. So our gradient is our change in y over our change in x, or our rise over run, however you want to think about it. It's 4 over 4, which equals 1. And there's our gradient of that line. All right, when determining the gradient between 2 points, we can still use our same formula of rise over run, or change in y and change in x. But this second formula will actually be a little bit easier to use. When we're considering a gradient between 2 points as well, we can just go straight to an answer. So for example, determine the gradient between the following pairs of points. Now, the first way we can do it is if we want to think about our changes. So the change in the x coordinate from 4 to 2, well, we've gone down 2 places. So the change in our x coordinate is -2. What about the change in our y coordinate? We started at 5, we've gone down to -3. So that's -8 spaces we've gone down. So, and some other ways of thinking about that, that's also 2 take 4, or that's also -3 take 5, however you want to think about it. And so therefore, our gradient is going to be change in y over change in x, -8 over -2, which is +4. Now in this last one, we've got, let's apply our formula this time. So we've got m equals y2 minus y1 over x2 minus x1. Now the key thing with using this formula is to make sure x2 and y2 go with the same, are with the same point, and x1 and y1 are with the same point too. Then substituting those values in, so y2 is 9 minus -1 over -2 minus 2. So that means we've got 10 over 0. We can't do 10 over 0. That must mean our gradient is undefined. And that makes sense. We've got our points here, -2, -1, and -2, 9. That's going to be a vertical line. Where there's -2, there's -1, and then let's say 9's up here. And there's my vertical line with an undefined gradient. All right, last one I want to look at, guys, is thinking about what does this actually mean in terms of real life? Now, when considering the graph of a life-related situation, the gradient is the rate that links our two variables. And the units will be y-axis unit per x-axis unit. So let me give you an example. Let's talk about y. this works. So let's say we're picking a point, I don't know, let's say this one here, that's going to be a 4, and that's going to be a 4 there as well. If we're going up in 2s, then let's say that one there is 20, and that one there is 12. Whoops, that one there is a 12. So what we're looking at here then is saying, well, what's our run, or the change in our x value? From 4 to 20, that's 16. But the thing is, it's not just 16. We're told along our x-axis that's measured in seconds. So that's 16 seconds. Now going upwards, what's our rise, or our change in y? Well, we've gone from 4 up to 12, so that's 8. Or we could say that's 12 minus 4, which is 8. But again, it's not just 8 because our y-axis is measured in meters, so that'll be 8 meters. Our gradient is our change in y over our change in x, which is 8 meters divided by 16 seconds, 0.5 meters per second. Notice now we've got a rate. So this gradient is actually now a rate, and this rate tells us the speed. So we've got this thing that's moving. This gradient has just told us how fast that car is moving just by looking at those units. It's that rate of change. In this case, it's talking about the speed of our object and how quickly it's traveling. Right, so after watching this video, guys, you should be able to calculate the gradient of a line from a graph, calculate the gradient of a line between 2 points, and also interpret the gradient in its context as a rate that links our x value and our x-axis to the variable on our y-axis.